My dears, last time we had discussed about parameters of a transistor, correct? Because this parameters formula will be very much useful to you in the numericals, I would like to give you nice revision for all these definitions and formula, okay? First of all, tell me what are called parameters. Parameters are those constants of a given transistor which describe its characteristics, which describe its properties, which describes its working in a circuit, okay? Such constants which can describe the given transistor completely are called its parameters. They are in all 5 parameters, okay? Let us see one by one. First parameter, look, Ri, what is it called? Input resistance, fine. And what is this formula? Delta VBE upon delta IB at a constant value of VCE. Now, we just give very short names to all these symbols. Look here, very simple it is. VCE, now onwards we will call collector voltage. Actually, it is potential difference between collector and emitter, but now onwards, as per textbook, we will call it collector voltage. As per textbook, we will call this as base voltage, correct? This IB means base current, correct? And delta, if it is there, then we should speak about their changes, okay? Now tell me, how would you define input resistance? At a constant collector voltage, the ratio of change in base voltage to the corresponding change in base current is called input resistance of a given transistor, shown by symbol Ri. I repeat, at constant collector voltage, the ratio of change in base voltage to the corresponding change in base current is called input resistance of a given transistor, shown by symbol Ri. And because it is some sort of resistance, its unit has to be ohm. Its value is found to be of the order of kilo ohm, okay? Now we go for second parameter, it is output resistance, shown by symbol Ro. Come on, what was the formula for that? It was delta VCE upon delta IC at constant base current, correct? Come on, define it this way. At constant base current, comma, the ratio of change in collector voltage to the corresponding change in collector current is called output resistance of a given transistor, shown by symbol Ro. I repeat, at constant base current, comma, the ratio of change in collector voltage to the corresponding change in collector current is called output resistance of a given transistor, shown by symbol Ro. Because it is also resistance, its unit has to be ohm, and its value we find approximately between 50 kilo ohm to 100 kilo ohm. Between 50 kilo ohm to 100 kilo ohm. Got it? Fine. We go for third parameter. It is none but current gain. Sometimes we call it current amplification. That current gain is shown by symbol beta. Its formula is delta IC upon delta IB at constant collector voltage. At constant collector voltage, correct. I am writing here constant. VCE equals to constant. VCE equals to constant. Fine. Now tell me, how would you define it? Simple. At constant collector voltage, come on, ratio of change in collector current to the corresponding change in base current is called current gain of a given transistor, shown by symbol beta. I repeat, at constant collector voltage, the ratio of change in collector current to the corresponding change in base current is called current gain of a given transistor, shown by symbol beta. Because it is a ratio of identical physical quantities, it has to be unitless. Fine. And its value is found to be between 10 to 1000, between 10 to 1000. Okay. Now we go for another parameter called transconductance. Its symbol is Gm. M you must write below G. Okay, like this. Fine. How would you define it? Ratio of change in collector current to the corresponding change in base voltage is called transconductance of a given transistor, shown by symbol Gm. I repeat, ratio of change in collector current to the corresponding change in base voltage is called transconductance of a given transistor, shown by symbol Gm. But mind well, what about its unit? It is now current upon voltage. Had it been voltage upon current, then its unit would have been ohm. But it is not voltage upon current, it is current upon voltage. So its unit has to be 1 upon ohm. But 1 upon ohm is nothing but mho, or it is also called in SI units, come on, Siemens. Siemens symbol is capital S, correct? So unit of transconductance is either mho or you may write Siemens, correct, which is 1 upon ohm. Then we go for the last parameter called voltage gain, shown by symbol AV. V you should write below A, okay, like this. Come on, ratio of change in collector voltage to the corresponding change in base voltage is called voltage gain of a given transistor, shown by symbol AV. Because it is also a ratio of identical physical quantities, it has to be unitless, okay. I repeat, ratio of change in collector voltage to the corresponding change in base voltage is called voltage gain of a given transistor, shown by symbol AV. Got it? Fine. Now we go further in the theoretical part of this chapter. Now in the further articles in textbook, and not only in this remaining part of this chapter, but in the next chapter, they have repeatedly used one word without giving any explanation. That word is signal. Now what do you mean by signal? In general, signal means any quantity which varies with time. Any quantity which changes with time is called a signal. But here in this chapter and in the later chapter, we are going to discuss about that electrical quantity which changes with time, like current or voltage. Then we will call it electrical signal. We will call it electrical signal, correct? So electrical signal is that electrical quantity like current or voltage which changes with time, okay? Actually we mean to say electrical signal, but just for sake of convenience, we will speak only signal. But you should understand it is electrical signal, okay? Fine. Now, amplification of weak signals. See, there are signals which are very weak, which need some amplification, which need some magnification, which need some strengthening. For example, in the output of a microphone, we get very weak audio signals. Then the TV and radio signals which we receive at the antenna at our residence, they are also very weak signals. Now in practice, to make them, to make proper use of them, we first of all require to make them magnified, we make them amplified. We try to strengthen them, okay? We try to increase their magnitude, and that process is known as amplification, correct? Strengthening a weak signal and converting it into a strong signal, that process is called amplification. Any circuit which will do this job is known as amplifier, okay? If it does the job of amplification of audio signals, we will call it audio amplifier. If it does the job of amplification of video signals, we will call it video amplifier. If it does power amplification, we will call it power amplifier, okay? Fine. Now, here I have shown the working of amplifier by simple block diagram. Here is in this box, suppose some amplifier is kept. Then what it will do, you know now, it will simply magnify, it will simply amplify the input AC signal. So the AC signal which you have, it is a very weak signal having very small amplitude and hence very small strength. This is very weak AC signal which we require to magnify. When we pass it through this amplifier, then in the output of this amplifier, we will get very magnified, amplified signal. That is what I have shown here, correct? Here amplitude is much more times this amplitude, okay, fine. Now, in our syllabus, we have to study about use of NPN transistor as common emitter amplifier. Use of NPN transistor as common emitter amplifier. Now, how we can use it? I am showing you. First of all, draw circuit symbol for NPN transistor. Remember, the middle terminal was base. This terminal on which arrow is put, it is emitter, and without arrow, this terminal is collector. Emitter, base, collector. And if it is NPN transistor, you may write NPN this way, or you may write NPN this way. No problem, correct? Fine. Because it is NPN transistor, I am supposed to show this arrow outward. Had it been PNP, then arrow should be shown inward. Because it is NPN, arrow is outward. Fine. Now tell me, emitter junction is to be forward biased. Emitter junction is to be forward biased. Then N with negative, N with negative. Look here, N with negative. In the input section of the circuit, emitter base junction needs to be forward biased. So N with negative. So this lower terminal is negative. When lower terminal is negative, naturally upper terminal will be positive. Now EMF of this battery connected with base, we just show it by symbol VBB as per the textbook, which we call base supply voltage. Okay, through this battery we supply forward bias to this base, correct? Fine. Now a signal source from which the signals are obtained, very weak signals, they need to be amplified. That signal source we connect here, and because it is AC source, we just put the symbol of AC source, correct? From this source we get signal voltage which is very low voltage, shown by symbol Vs. It is called signal voltage. Though we are writing Vs, we mean to say RMS value of this voltage. RMS value of this voltage, it is Vs. Okay, fine. And that signal is, suppose this signal, which is very small, very weak signal. Now, come on, collector junction is to be reverse bias. Collector is right now N-type semiconductor, and if you want to give it reverse bias, then N with positive, N with positive. So here upper terminal is to be shown positive. If upper terminal is positive, naturally lower terminal will be negative. And this reverse voltage is more than this forward voltage. So here we are showing one battery, and here we are showing two batteries, correct? EMF of this battery connected with collector is to be shown by symbol VCC as per the textbook. We call it collector supply voltage. Collector supply voltage. Fine. And now tell me, here we connect some resistance called load resistance, correct? Actually, we are not connecting that resistance. What we are getting here between these two terminals, we get amplified AC signal, amplified. Now that amplified AC signal is to be used to run some device, okay? So in whichever device you require that amplified voltage, that device is connected here. But when you connect it here, that device has got its own resistance, and that resistance is known as load resistance, okay? Fine. Now, in this direction of arrow, you will just continue and you will show the current, coming from emitter. So I just call it emitter current, shown by symbol IE. After coming to this junction, will be divided into two parts. That part of the current flowing through base should be shown by symbol IB. We call it base current. And rest of the part of the current will be flowing through collector. We call it collector current, shown by symbol IC. So IE is getting divided into two parts, IB and IC. That's why last time we had said that IE equals to IB plus IC, correct? Fine. Now here you must show this terminal to be grounded. What do you mean by this terminal being grounded? See, Here this is input part of the circuit, this is output part of the circuit. In both the parts emitter is common. That's why we call it common emitter. And we can call it grounded emitter also, because emitter terminal is grounded. Making any terminal grounded means its a potential we are going to take 0. If potential of this terminal is 0, then potentials of these all terminals are to be taken 0. Any terminal whose potential is 0 is said to be grounded. And now with respect to this 0 volt terminal, we are going to measure potentials on other terminals. Okay. So this is taken as reference potential, which is 0. That's why the terminal is said to be grounded. Fine. Now how it works? How amplifier amplifies the AC signal, I am showing you. Mathematically we can just show it this way. First of all, what are we doing here? We are supplying, come on, in the input signal voltage Vs. When you supply this signal voltage, naturally it will change potential between base and emitter. This signal voltage supplied will change the potential difference between base and emitter, which we call base voltage, correct? So when you supply this signal voltage, this base voltage is getting changed. Let it change to value delta VBE. Change in base voltage I am showing by symbol delta VBE, correct. Now because the base voltage is changed, because of that base current also will change. Come on, in the input if you are changing the voltage, naturally the current also in the input will change. If IB is changing by amount delta IB, then what would be change in collector current? You know beta formula, beta is delta IC upon delta IB. So delta IC will be beta into delta IB. Come on, delta IC will be beta into delta IB. When base current changes by amount delta IB, collector current would change by amount beta into delta IB, beta into delta IB. Because beta value is very much greater than 1, this change in collector current is very large. And if large change in collector current, if you allow to pass through load resistance, then across that load resistance we will have very high, very big change of voltage, and that is called output voltage. Okay, that output voltage here it is found to be very large. That's why we are showing here very big signal. This is the weak signal, this is a very strong signal. Okay, so input signal is being amplified using this circuit. That's why we call it amplifier. Correct? Fine. Now let us now mathematically analyze the working of this circuit. How does it work? Let us analyze mathematically. First of all, we take the part which is input part of the circuit. We call it input circuit. Come on, in this input circuit, come on, if signal voltage is not applied, then we can write when Vs is not applied. In the absence of Vs, when this signal voltage source is not connected, the voltage between these two terminals is VBB, and same voltage will appear here also between base and emitter, which we call VBE. In short, in the absence of Vs, these two voltages will become equal. VBB equals to VBE. Come on, VBB equals to VBE. Correct? Now let us see what will happen if Vs is applied. If Vs is applied, what will happen? When you supply this signal voltage, at that time, the total potential difference between these two, that is total voltage between these two, will be algebraic summation of these two voltages. So it will be Vs plus VBB. Come on, Vs plus VBB. Vs plus VBB. Correct? Now tell me, because of VBB, you are going to get VBE. Because of VBB, I am going to get VBE. But on left hand side, you are not writing only VBB. You are writing Vs plus VBB. So you are making change on left hand side. When we make change on left hand side, same change would appear on right hand side. On right hand side, whatever is the change in this value, that I am showing by symbol delta VBE. But mathematically these two are equal. When these two are equal, they will cancel. They will cancel. Giving you Vs equals to delta VBE. Vs equals to delta VBE. Tell me what is equal to what? Signal voltage supplied. Supplied signal voltage is just equal to change in base voltage. Change in base voltage. Correct? Now this supplied signal voltage or change in base voltage itself is known as input voltage. What is it called? Input voltage. So whether you say input voltage or signal voltage or change in base voltage is one and same. And why it is equal to Ri into delta IB? Recall the formula of Ri. What was the formula for input resistance? Come on. Formula for input resistance was Ri equals to delta VBE upon delta IB. Here it is. Delta VBE upon delta IB. Find out delta VB from here. It will be Ri into delta IB. Come on, Ri into delta IB. Correct? Please remember this small formula will be very useful to you in the numericals. Okay? Signal voltage is equal to change in base voltage. Fine. Now we go for analyzing the output part of the circuit. Now take this output part and consider this loop. Consider this loop. Fine. Now in this loop we apply Kirchoff's second law. What does it state? Very simply speaking, total voltage applied should be equal to summation of voltages obtained. Come on, total voltage applied in this loop is supplied through this battery, and that supply voltage is collector supply voltage, which is VCC. So total voltage applied is VCC, and part of that will be obtained across RL, because current passing through RL is IC. You know, potential difference developed across this resistance according to Ohm's law. It is current into resistance, IC into RL, IC into RL. So one part is obtained across RL, it is current into resistance, and remaining part is obtained between these 2 points. Between these 2 points. And that part is nothing but potential difference between collector and emitter, which I am showing by symbol VCE. Come on, rest of the voltage is obtained here between collector and emitter, and which we show by symbol VCE. So I am writing plus VCE, correct? This is the voltage across RL. This is potential difference between collector and emitter, and total supply voltage is VCC, correct? Now tell me, just take changes on both the sides. Come on, change in VCC, I am writing delta VCC. Change in IC, I am writing delta IC into RL. Change in this value, I am writing delta VCE, correct? Fine. Now because this collector supply voltage is constant, see, EMF of any battery is constant. Because this VCC is constant, change in constant quantity would be 0. Because VCC is constant, change in constant quantity has to be 0. So this value is 0, this value is 0, I am putting here 0, correct? And right hand side I am writing same. Now just find out delta VCE, transfer this. From plus it will become minus. Delta VCE equals to minus delta IC into RL. Just now I said this change in collector voltage, it is only known as output voltage. It is only known as output voltage. Change in base voltage will be called input voltage. Change in collector voltage will be called output voltage. So change in collector voltage should be called output voltage, shown by symbol VO. Don't say V0, it's not V0, VO, output voltage. Now this right hand side as it is, fine. Now tell me, this is VO equals to minus delta IC into RL. Now just recall the formula of voltage gain. What was voltage gain? Here it is. Voltage gain was, come on, change in collector voltage divided by change in base voltage. Come on, change in collector voltage, it is nothing but output voltage, correct? Divided by change in base voltage, but change in base voltage is nothing but Vs, so I am writing here Vs, correct? In fact, this is output voltage, this is input voltage. Ratio of output voltage to input voltage is called voltage gain. What about VO formula? Minus delta IC into RL, here it is, minus delta IC into RL. What about Vs? Vs formula is this much. Vs is this much. Ri into delta IB. Look here. Ri into delta IB. Correct? Now tell me, this minus sign as it is, but delta IC upon delta IB. Look, delta IC upon delta IB, it is nothing but beta. Come on, delta IC upon delta IB is nothing but beta. So in place of delta IC upon delta IB, I am writing beta into RL upon Ri. Into RL upon Ri. Correct? Now this voltage gain AV as it is, minus as it is. Last time we had obtained one small formula, GM equals to beta upon Ri. GM equals to beta upon Ri. What was GM? Transconductance. Its formula was beta upon Ri. Now speak reverse. Wherever it is beta upon Ri, we can write GM. Come on, wherever it is beta upon Ri, I can replace it by GM. into RL as it is. AV equals to minus GM into RL. Voltage gain equals to minus GM into RL. What does this negative sign indicate? Look, negative sign indicates that voltage gain is negative, meaning thereby output voltage signal is negative of input voltage signal, meaning thereby output signal is inverted of input signal. Output signal phase wise, you can say it is having 180-degree phase with input signal. How I am showing you? In the input signal, if there is a crest, first of all if you are saying crest and then trough, because output signal is inverted of input signal, here first of all we should show trough and then crest. Here firstly crest, then trough, here firstly trough and then crest, because this signal is inverted of this signal, okay. And what is the phase difference between crest and trough? It is 180-degree. It is said to be out of phase. It is said to be out of phase. Output signal in case of common emitter amplifier is out of phase as compared to input signal. There is a phase difference of 180-degree between input signal and output signal. So negative sign shows that output signal and input signal are just opposite phase wise, okay, fine. They are out of phase and the phase difference is 180-degree. I am writing here phase difference is 180-degree, fine. Now we go for power gain. Power gain is shown by symbol AP. What do you mean by power gain? Very simple. Ratio of output power to the input power. Ratio of output power to the input power is called power gain. Now this AP as it is. But here we are talking about electrical power. For electrical power, what is the formula? Voltage into current. Voltage into current. But here we should take product of changes. Change in voltage into change of current. Change in voltage into change of current. Come on, because you are talking about output part of the circuit, we should write here change in collector voltage into change in collector current. These both the quantities belong to output part of the circuit. That's why such a product of voltage and current will give you output power. Similarly, what about input power? Change in base voltage into change in base current. You know voltage into current will give you power, but because these two quantities belong to input part of the circuit, this product will give you input power. Fine. Now, delta VC upon delta VBE, it is nothing but voltage gain. Look, voltage gain AV is nothing but delta VCE upon delta VBE. So this delta VC upon delta VB can be replaced by AV, and delta AC upon delta IB. Delta AC upon delta IB, you can just show it by symbol beta also, and here I am showing as per the textbook by symbol AI. AI means current gain, AV means voltage gain. This voltage gain as it is, but symbol of current gain, another symbol of current gain is beta, correct? This AI and beta, they are equal, they are equal. Now, come on, AP as it is. What about formula of AV? Formula of AV is, come on, here it is. Formula of AV is minus beta into RL upon RI. Minus beta into RL upon RI. Into this beta as it is. Now tell me minus as it is. Beta into beta, beta square into RL upon RI. Into RL upon RI. Remember, formula of voltage gain is minus beta into RL upon RI. Formula of power gain is minus beta square RL upon RI. Here only single beta and here beta square. Got it? And if you take magnitude of this, come on, mod of AP will be mod of this. From minus it will become plus beta square RL upon RI. Come on, beta square RL upon RI. Correct? Now tell me, here you are getting some power gain. But what is the reason for increase in the power? You are getting some power gain means what? Output power is more than input power. Output power is more than input power. Then does it mean that here electrical energy is produced? No. According to law of conservation of energy, energy is neither created nor destroyed, correct? Energy can be transformed from one form to another form, correct? So here how we are getting increase in the output power at the cost of which energy? I am showing you. Look. See, here in this battery, energy is stored in the form of DC, and that energy stored in the form of DC gets transformed into, come on, energy in the form of AC, and that's why we are getting amplified AC signal, correct? So increase in AC power is at the cost of energy or power stored in this battery in the form of DC. Energy stored in the form of DC is getting transformed into energy in the form of AC. That's why we are getting some power gain. Okay. After some time, when this total energy is consumed, we have to replace this battery. Okay, fine. Now, kindly read this statement of illustration number 4. Illustration number 4. Read it? Come on. For common base circuit, what was the formula for alpha DC? Alpha DC formula was IC upon IE, IC upon IE. And when you are not writing alpha DC, we mean to say AC gain, alternating current gain for common base. It is shown by symbol only alpha, and its formula is delta IC upon delta IE. Come on, delta IC upon delta IE, correct? If it is alpha DC, it is IC upon IE. If it is only alpha, we mean to say AC gain, then it is delta IC upon delta IE, correct? Fine. For common emitter, that current gain is shown by symbol beta, and it is delta IC upon delta IB. If it is beta DC, you may write IC upon IB, but if it is only beta, we mean to say alternating current gain, and then you should write delta IC upon delta IB. Come on. You know, emitter current is always a total current, which is a summation of base current and collector current. Come on, take delta on both the sides. Delta IE equals to delta IB plus delta IC. Divide each term by delta IC. Come on, delta IE upon delta IC. Here delta IB upon delta IC plus delta IC upon delta IC. If it is delta IC upon delta IE, we can write alpha. But if it is the, come on, inversal of this, then delta I upon delta IC, it will be 1 upon alpha. Come on, just take the reciprocal. Come on, delta I upon delta IC will be 1 upon alpha. So delta I upon delta IC can be written as 1 upon alpha. If it is delta IC upon delta IB, we can write beta. But if it is the inverse ratio, then come on, delta IB upon delta IC, it will be 1 upon beta. Take reciprocal here, delta IB upon delta IC will be 1 upon beta, delta IB upon delta IC is 1 upon beta, plus delta IC upon delta IC is 1. Find out 1 upon beta from here, transfer this 1 on this side will become minus. Take LCM, 1 minus alpha upon alpha, 1 minus alpha upon alpha, and then take reciprocal on both the sides. So beta will be alpha upon 1 minus alpha, beta will be alpha upon 1 minus alpha, beta will be alpha upon 1 minus alpha. Okay. In textbook they have asked some additional question. Similarly, we can obtain the formula of alpha. That is what they have said. Let us obtain here. Very simple it is. Find out alpha from here. You will find it easy. Just take LCM here. 1 plus beta upon beta. 1 plus beta upon beta. Here it is. 1 plus beta upon beta. Correct? And now take reciprocal on both the sides. Come on. Alpha will be, come on. Take reciprocal here. It will be beta upon 1 plus beta. Come on. Beta equals to alpha upon 1 minus alpha. And alpha equals to beta upon 1 plus beta. This is formula of beta in terms of alpha. This is formula of alpha in terms of beta. If you can remember both, well and good. But if you cannot remember both, at least remember one formula, because it will be useful in the numericals. Beta equals to alpha upon 1 minus alpha. What is alpha? Current gain in case of common base circuit, and beta is current gain in case of common emitter circuit. Got it? Fine. Now kindly read the statement of number 5, illustration number 5. Read it? Come on. Emitter current is formed by that number of electrons which are entering from emitter into base, correct? That charge divided by time. Charge divided by time will give you charge per unit time, which is called current, but right now we are talking about emitter current. So I am writing symbol IE. Now this charge, suppose n number of electrons, capital N number of electrons transfer from emitter into the base in T time. So what is the charge equivalent? Come on. For one electron, the magnitude of charge is small e. For n number of electrons, the charge will be n into e. So this charge is n into e, correct? Divided by this T as it is. Now tell me, number of electrons going from emitter into the base, they have given as 10 raised to 10. This is magnitude of charge of one electron, which everybody must remember, 1.6 into 10 raised to minus 19 coulomb. But this time we must take in second. What is given to you in the statement? 1 microsecond. Microsecond you must convert into second. Multiply by 10 raised to minus 6. Now this answer is 1.6 into 10 raised to minus 3, that many ampere. Okay. But 10 raised to minus 3 ampere is nothing but 1 milliampere. So this is as good as 1.6 milliampere. 1.6 milliampere. Now what is given to you in the statement? Out of the number of electrons entering from emitter into base, only 2% of that number associates with the holes, correct? So base current constituted will be simply 2% of total current, that is 2% of emitter current. Base current constituted is 2% of emitter current. Now 2% of IE, how will you find out? IE into 2 divided by 100. When you want to find out 2%, multiply by 2, divide by 100. Multiply by 2, divide by 100. Fine. This IE is how much? 1.6 milliampere into 2 upon 100 as it is. And now simplify, answer is 0.032, this many milliampere. Because this current you are taking in milliampere, naturally this will be obtained in milliampere. What about IE? Formula is known to everybody. IE equals to IB plus IC. What about IE value? We have found out 1.6 milliampere. IB is 0.032 milliampere plus IC. And now IC you can find out from here. Answer is 1.568, that many milliampere. Got it? What about alpha DC? Come on, for common base circuit, the DC gain is alpha DC. It is ratio of IC to IE. What is IC value? We have found out 1.568 divided by IE is 1.6, correct? This upon this, answer is 0.98. And what about the current gain in case of common emitter? DC gain in case of common emitter is shown by symbol beta DC. It is a ratio of IC to IB. IC we have found out, come on, 1.568 divided by IB. IB is 0.032. This upon this, answer is 49. Or you may do one thing, you can put this value of alpha over here. Put the value of alpha, which is 0.98 here also and here also. Simplify, you will get value of beta, same value, 49. Okay. You know alpha is always less than 1, here it is 0.98 is less than 1. And beta is always greater than 1, here it is 49. Okay, fine. Now kindly read this statement of illustration number 6. Read it. Input resistance of a given transistor is, come on, given by this formula, Ri equals to delta VBE upon delta IB. Same formula written here. Come on, this is change in base voltage, and change in base voltage. Change in base voltage is as good as signal voltage, correct? Given to you as 0.02 volt. 0.02 volt. Sometimes they may give 20 millivolt. 20 millivolt, then millivolt you must transform into volt. 20 millivolt, when you transfer into volt, 20 into 10 raised to minus 3, which will be 0.02 volt, correct? What about change in base current? They have given 20 microampere, convert it into ampere, multiply 10 raised to minus 6. Simplify. Because you are taking this value in volt, this in ampere, volt upon ampere will give you ohm. Answer is 10 raised to 3 ohm. Come on, beta. Current gain beta equals to delta IC upon delta IB. This is change in collector current given to you as 2 milliampere, converted into ampere, multiplied by 10 raised to minus 3. What about change in base current? They have given 20 microampere, converted into ampere, multiplied by 10 raised to minus 6. Now when you simplify, answer is beta equals to 100. Okay. Now tell me, because this is current gain, it has to be unitless. What was the formula for transconductance? Last time we had obtained Gm equals to beta upon Ri. Come on, Gm equals to beta upon Ri. What is beta value right now? 100. Ri is right now 10 raised to 3 ohm. Simplify, answer is 0.1. And unit of transconductance, just now I said it is mho, symbol is this, or you may write Siemens. Siemens symbol is capital S. Okay, fine. Now what about voltage gain? Voltage gain is given by formula minus Gm into RL. Here it is. AV equals to minus Gm into RL. Come on, AV equals to minus Gm into RL. This minus sign as it is. Gm, transconductance, how much it is? 0.1 mho. And what about load resistance? They have given 5 kilo ohm. 1 kilo is 10 raised to 3. Kilo means 10 raised to plus 3. Milli means 10 raised to minus 3. Here load resistance is 5 kilo ohm. You must convert into ohm. Multiply 10 raised to plus 3. Answer is minus 500. Correct? And now tell me, when you take magnitude, mod of AV will be magnitude of this. From minus it will become plus. What about modulus of power gain? It is a product of modulus of voltage gain and current gain. But current gain AI can also be shown by symbol beta. This voltage gain magnitude we have found out 500. Beta also we have found out to be 100. Put it here. 500 into 100, that is 5 into 10 raised to 4. Any sort of gain, might be current gain, voltage gain, power gain, every gain is unitless. Okay. Kindly read the statement of sum number 7. Read it. Come on, beta. In case of DC gain for common emitter, what is the formula for beta? IC upon IB. Find out IC, it is beta into IB. Beta, current gain you are given in the statement 300. Base current you are given 10 microampere. Convert into ampere, multiply by 10 raised to minus 6. Now simplify, answer is 3 into 10 raised to minus 3, that many ampere. Fine, leave it in ampere only. And now apply Kirchoff's second law in the output part of common emitter amplifier. Come on, just now we have seen this common emitter amplifier circuit. In this output part, when we had applied Kirchoff's second law, we got this equation. Look here, VCC equals to IC into RL plus VCE. Everybody, VCC equals to IC into RL plus VCE. Here it is. VCC equals to IC into RL plus VCE. Correct? So please remember every formula in the theory. Anytime any formula will be useful to you in the numericals. Please. Come on. VCC is called collector supply voltage, which they have given in the statement as 10 volt. This IC we have found out 3 into 10 raised to minus 3 ampere. Load resistance we want to find out. What about VCE? It is called, come on, collector voltage or potential difference between collector and emitter, which they have given as 4 volt. Simplify. Value of RL you will get 2 into 10 raised to 3, that many ohm. But if they ask this value in kilo ohm, you know very much 10 raised to 3 ohm is nothing but 1000 ohm, which is 1 kilo ohm. So it is as good as 2 kilo ohm, right? Small k here, correct? Read number 8 now. Come on. In case of oscillations in LC circuit. What was the frequency of oscillation? We had studied earlier. F equals to 1 upon 2 pi into under root of LC. Come on, L is called inductance, C is called capacitance. Now just take squares on both the sides, it will be very easy for you. Come on, take square, it will be F square. When you take square, it will be 1 upon 4 pi square, and when you take square, this square root will vanish, giving you L into C. And now, because for a given circuit, this inductance is constant, 4 pi square is as such constant only. So relation between F square and C would be F square proportional to 1 upon C. F square proportional to 1 upon C. Now tell me, if it is inverse proportionality, then 1 to 2, 1, 1 to 2, 1. So I can write here F1 square upon F2 square equals to, come on, C2 upon C1, 1 to 2, 1. Now because both these frequencies are given to you in megahertz, then just keep them in megahertz only, because when it is megahertz upon megahertz square, it will be getting cancelled, correct? Whenever it is a ratio of same physical quantity, and if both the values have got same unit, you just don't change the unit, okay? Leave these two frequencies in megahertz only, no problem. First frequency is 1 megahertz, second frequency is 2 megahertz. First capacitance value, they have given 100 picofarad. Because C1 you are taking in picofarad, naturally C2 also will be obtained in picofarad, and that C2 value you will get here 25 picofarad. This is 1 by 4, 100 will go here, 100 by 4, that is 25 picofarad. You know what is pico? It is 10 raised to minus 12. Remembered? Deci, centi, milli, micro, nano, pico, femto, atto, zepto, yocto. In that, pico means 10 raised to minus 12. Okay? Fine. Now just one more thing. Suppose they ask only circuit diagram for this common emitter amplifier, but not using NPN. Say if they are asking for using PNP transistor, then I told you last time, you are supposed to make 5 changes, correct? Which 5 changes I am showing you? Look, here the meters are not connected, so you can make 4 changes. Which 4 changes I am showing you? Come on, instead of NPN, you should write PNP. PNP this way or PNP this way, no problem. Instead of showing arrow outward, you will show it inward. These currents, you will just make them reverse in the directions, correct? Directions of all these currents must be reverse, and polarities of these two batteries also must be reverse. These 4 changes you can make in this circuit, okay? But for that circuit to be true, you must remember this circuit perfectly, okay? Do enough practice. Just draw it minimum 4 to 5 times, okay?